Welcome. This is another technical technician video brought to you from Diagnation. And today we have believe it's a 2011 Ford Expedition that came from another shop that the vehicle was having blower motor issues. The blower motor was in and out, and the other shop replaced a blower motor and a blower motor speed control module, and it worked for a few days, and then it got in our hands, and we kind of attacked it with a scope right off the bat. I will show you a real simple but accurate schematic on how we were hooked up. You see right here, you want to take a screenshot. I'll get my thumb out of the way. It is a Ford Expedition blower motor circuit. Take a look at that, take a screenshot. You can see the blower motor. Below that is the blower motor speed control module. And then to the right of that is the HVAC module. The HVAC module, the operator controls the HVAC module, and it sends a control signal to the blower motor speed control module, and it actually varies the voltage drop on the ground side of the blower motor to control the blower speed. So basically, we're hooked up on two channels on the scope. We've got channel A is an amp clamp on the ground side. I don't know if it's the ground side or the hot side of the blower motor. It really doesn't matter because it's current flowing. And channel B is on the ground side of the blower motor itself, not the feed side of the blower motor. So take a screenshot of that, and then we'll get to the scope, and we'll take a look at what's going on. I started out hooking those. My first channel I hooked up was the amp clamp to the blower motor, and right around here is when I hooked up channel B to the ground side of the blower motor. You can see we're probably flowing at full speed right now. We're pulling about 20 amps at the blower motor, and on the ground side of the blower motor we have a voltage drop looks like 761 millivolts. So the blower motor is working. Evidently this problem is very intermittent. So as I go through the capture, we'll start to see things. I start to manipulate the blower speed at the HVAC module, and we can see we have a dip in current here, which is normal. We have a controlled voltage drop here on red because the control signal from the HVAC module goes into the blower motor speed control module, and that thing varies actually it's basically a variable resistor within there, and that changes the resistance. So the blower motor spins at a slower speed. It's got more, I guess we call it controlled voltage drop on its ground side. So I continue to do so, and right here is where this is probably low speed right here, where we dial in more so resistance on the ground side. Let's see how much voltage drop that would be. That looks about 9 volts of drop. So consequently our amperage will go down. That's Ohm's law. And we know that our amperage is about 4 amps. So that blower motor is not spinning very fast. That would be low speed. And this problem is, as I said, is very intermittent. I believe when I was working on it, somebody might have opened the door and it quit. But here's when we're going to see things get a little more conclusive. But here's his normal operation. The resistance is decreasing on the ground side. This is the control, and hence our amperage is increasing on the top side. So right here, I believe somebody opened the door and slammed the door, and this is what happened. We're starting to see something here. This is a little odd. Let's kind of key in on this. We got a little bit, let me do some vertical zoom here because that's kind of interesting. Yeah, we got a little action here. There's something here. I think there's some vibration going on, but nonetheless, it gets more convincing. We got a little bit of, well, that doesn't look controlled or desired, and hence we see a little bit less amperage flowing. So that's starting to tell us something. Somebody banged as I said, here we go. Here we got something pretty concrete. That doesn't look natural or controlled. That's unwanted voltage drop. It's very abrupt, and then hence our current starts to lessen. And then we continue to go to the next slide, and we see this stuff. This is the money shot right here. You can see our voltage drop abruptly go up and our current abruptly go down, and then right here is where the motor quits. You can see where right here we got a little jaggedy here, and then the voltage drop, the actual ground side. And as you look at your schematic, and I hope you printed it out or roll the video back to the schematic, you'll notice a green X on the ground wire to the blower motor speed control module. It's just a 4-pin connector, and I noticed that the ground pin on the connector was burnt. So basically what we had to do is we had to order a connector from Ford and solder in 4 wires. But you can see the effect when we vibrated the vehicle or shook the connector. We can see we had a total loss of current. You can see the current go completely to 0 there, and the voltage drop pretty much as an open circuit here. I'm sorry, I noticed one thing I forgot to tell you at the beginning. The green channel is just disregard the green channel. I'm sorry, I should have told you that initially. That basically wasn't doing anything. I did not use it. But then right here we can see we have pretty much an open circuit here. We're looking at about battery voltage when we get to, let me get to the top of it right here. Let me kind of undo the vertical zoom, and you can see it. Okay, this is our red channel, and we can see that we're almost pretty much battery voltage when the circuit opened, because there is no ground. So about right here, we're looking about running voltage. That was like 1303, but nonetheless, you get the idea. As you look at at that big hashy red area, that's that open circuit at that connector pin, because there is nowhere for that current to flow, and it just backs up when you get full voltage at the ground side of the blower motor. So what we did is we got as I said, we got the connector and we soldered in the 4 wires, and the thing worked consistently. Anyway, thanks for watching. Take care.